Swayam Prabha. Digital India. Educated India.
Once again, I welcome you to this soil mechanics lecture. Let me continue from my previous lecture. What I have ended last lecture was using Boussinesq's theory, and initially I have applied which was originally for, of course, point load, and then I have extended to uniformly loaded circular area, then uniformly loaded rectangular area, and if in the uniformly loaded rectangular area, that is known as corner formula. And if you know the corner formula, then by using in several combinations we can find out stresses at different points, different desired points, and how it could be done, that I have shown. Now, I will show some of the other aspects, like if the foundation shape is irregular, then sometime we will not be able to do whatever method we have discussed. So, that is the point I will try to discuss now. That is the method we use for this is Newmark's influence chart, and this for this Newmark's influence chart, whatever already we have done for circular loaded area are integrated, and finally, we have got a expression got an expression sigma z equal to q times 1 minus this term. Now, I can just simplify sigma z by q, and then I can write this expression. Now, if I want to make sigma z by q is 0.1, 0.2, 0.3, it means actually whatever sigma z whatever pressure applied to the surface, it is of 10% of that, 20% of that, 30% of that. Okay. So, that value, suppose 10% of surface stress, if I, that is the ratio, suppose if it is a 0.1, if I consider, then it is nothing but 10% of the surface loading. So, for that, what should be the R by Z? So, by solving this, suppose if I put 0.1 here, then I can solve this from this equation what should be the R by Z. So, for that actually what I have done here, for several values of sigma z by q, that is 0, then obviously R by Z has to be 0, and when it is 0.1, R by Z is 0.27, when R by Z equal to, sigma z by q is 0.2, then R by Z is 0.4. Similarly, sigma z by q is 0.3, that means 30% of the surface load, then R by Z is 0.52, like that it is going, and when it is 100%, that means whatever load you have applied at the surface and same stress will be there. So, theoretically R by Z will be infinity. So, that is the one. So, what is the meaning of it actually? The meaning of it actually, if I want to make the pressure intensity at a particular depth. So, different radius of circle I can think of, and at the same depth I can find out what could be the pressure. So, by using this actually there is a chart can be prepared, that is called Newmark's chart, and the principle of Newmark's chart is, suppose we have got R by Z, different R by Z, and suppose our intention or main purpose is to find out the stress, vertical stress at a depth Z. Suppose Z can be anything, suppose 2 meter, 4 meter, 6 meter, 8 meter, anything. So, in this R by Z ratio is there. So, from there if I fix a Z value, suppose 2 meter, and that 2 meter distance or depth, I will take some length of some length, suppose this 2 centimeter, 2 meter equals to 2 centimeter, then automatically from r by z, if I fix, then I will get from there what is the value of r. So, if I keep z constant throughout, z is actually 2, then what I will get? I will get for different intensity, I will get different r. What is the meaning of it? That means at 2 meter depth, if I want to get 10% of the surface load, then whatever the circular area to be loaded at the surface, I will get some value, that is suppose r1 radius. Now, at same depth, if I want to get the pressure of 20%, then your circular area loaded will be different, and that will be suppose r2. So, let me I will do fresh in the next slide. So, that means I can do, let me take a better one fresh page. So, suppose I know r by z, and r by z actually suppose two values r by z equal to, if I go back, r by z is 0.27 and 0.4, suppose r by z 0.27 and r by z equal to 0.4. Now, if I fix the depth equal to z 2 meter, then r will be some value, suppose that is suppose r1. That means, if the circular load area is r1, something with radius r1, and that much load area if loaded with intensity q, at 2 meter depth your intensity will be 0.1 q. Similarly, now if I now do r by z equal to z is same. Now, if I do same, then 0.4, this is the 0.4. So, r will be equal to, that is actually for 20%. So, that will give you r2 equal to some value. Here actually given r1 corresponding to 2, here r2 corresponding, they are getting some other value. Now, if I draw another circle with r2, another circle of r2 with radius r2, what is the meaning of it? That means, that much area if it is loaded uniformly with pressure q, then at same depth 2 meter you will get 0.2 q, 0.2 q. Now, if I do what I will do, I have done point, suppose I will draw now separately, I will clean this one, I will do separately, that is suppose this is the radius for 0.2 q, this is for this is suppose r2 for 0.2 q, and there is another circle, this is suppose with r1, and that is suppose for 0.1 q. Now, once I am loading with 0.2 q, r2 with q, and you are getting at the center 0.2 q, and once you are applying with r1 with q loading, and you are getting 0.1 q. That means, if I only load this area, if I only this load area at same depth, what will be the stress actually? This was 0.2 q for the whole area, and inner area 0.1 q. So, difference of these two, that means 0.2 minus 0.1 q will be equal to 0.1 q. So, that means, this area is 0.1 q, the whole area is a 0.1 q to 0.2 q. So, that means, that differential that between the two circle, that will be 0.1 q. Suppose like that. Similarly, if I now keeping the z same, I will do r3, r4, r5, r6, like that different circle I will draw. If I draw different circle now, if I draw different circle now like this with different radius, then what will happen? Whatever may be the radius, if depth is constant and corresponding to that if you get the radius, now each annular area, effect of each annual area at the same depth will be constant, that is 0.1 q. So, that is the idea will be used for drawing the chart. So, that means, we have shown that for 0.1 q, 0.2 q, 0.3 q, 0.4 q like that, corresponding r by z you have got. Now, I have fixed the z, then corresponding r 1, r 2, r 3, r 4 if I draw. Now, with that radius r 1, r 2, r 3, r 4, finally, r equal to infinity will be their last circle. So, between the two circles, the influence at the center at the constant depth 2 meter suppose will be same. That means, each annular area effect at the center will be same. So, that is the important observation to be used for drawing the chart. So, now, so this is the concept if I use now this is the way you can see this is the way it is done already. So, suppose this is the first circle, then this is the second circle, the third circle, fourth, fifth, sixth, seventh, eighth, ninth and 10th circle was infinite. It can be big, suppose I am keeping it may not go or need not go up to infinity, but some finite depth other part will be bigger. So, now effect of this annular area and effect of this small annular area at the center will be same. How it is same? See, it is from this point this area is far. So, effect is but area is large, but it is far, whereas this area is small, but it is closer. So, because of this effect, the net effect will be this one and for this one will be same. So, this way you have drawn so many circle. Now, once again if I this circle if I divide by divide a number of parts by drawing radial lines like this. So, you can see we have divided into 20 parts. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and similarly 10, 20 parts. So, one each will be of 18 degrees. So, now when you have divided again we have done 20 radial lines. Now, again those circles also divided to small parts. Now, the way I have observed that each annular area is having same effect on the center. Similarly, when you divide by drawing radial line, so this part whatever effect will be there, this small part also will be having same effect at the center. So, that is the main conclusion from this drawing. So, that means, now this will be utilized to find out vertical stress at any depth for any shape of foundation type. So, how to utilize this? So, that is the depth as I have mentioned. For drawing this you have to fix the depth. So, for any influence chart you have to fix the z part and whatever z that should be kept along with this chart. So, that is why here actually this line is drawn and that was written this is a z. So, now what will happen if suppose there is a foundation and I want to find out at 5 meter depth pressure. So, that depth 5 meter. So, whatever line length is given here, that length will be taken as, so whatever length is given z, that will be taken as 5 meter, because I want to find out pressure at 5 meter depth. So, that depth z should be equal to 5 meter. So, that is the scale now. So, whatever z, suppose this was 2 centimeter or 5 centimeter, suppose it is 1 to 4 centimeter, suppose this length. So, 4 centimeter equal to 5 meter, that become the scale. So, whatever foundation, suppose it is foundation is this much big, 2 meter by 3 meter. So, 2 meter by 3 meter foundation, now 4 centimeter equal to 5 meter with that scale to be drawn. And now, suppose I want to find out the pressure at this point. So, that point could be kept here and that scale down the foundation will be put on this diagram, keeping the point on the center where actually you want to find out the pressure, and then it will be covered by some blocks. It will cover some blocks, number of blocks, and you have to count the number of blocks, and each number of blocks will have same influence, and that influence value for this chart is fixed. What is the value? Because you can see initially 10 circle and again circle is divided into 20. So, 10 into 20, 200 we have divided. So, 10 into 20. So, 200. So, that means this entire circle is divided into 200. So, if I cover the entire circular area, the value is 200. So, if I cover by 1, then it will be value is 1 by 200. So, that is called influence value. So, when I cover by 1 only, that is called influence value, that is 1 by 200, that means 0.005. Okay. So, now with that particular scale, if I draw the foundation, and that foundation I will put in this chart, and then I will see how many blocks are covered by that foundation, and that number of blocks multiplied by this influence number, influence value multiplied by Q, that gives you the pressure. So, that is the thing I have given step by step what to do in the next slide. You can see here method for drawing Newmark's chart. First thing is you have to draw a line of any length representing the depth, that is suppose 2 centimeter line. Suppose I have to draw the chart, I have to fix the length in such a way, suppose I will use A4 size paper. So, 9th circle at least it should come within the paper. So, 2 centimeter, 3 centimeter, anything can be taken, and that should be that line also drawn at the side, because that is the scale used for drawing this influence chart. Find out for different sigma z by q ratios, say R1, R2, R3, R1, R11, like that, different radius whatever I have shown, that to be calculated. Draw circles with different radius so obtained. So, you have to draw circles R1 with R1, R2, R3, and between R1 and R2 whatever the circular annular area influence is same as what is between 2 and 3, what is between 3 and 4. So, that is known, I have explained logically. Draw radial lines dividing the whole circle into 20 equal parts. It can be done any number actually. So, we preferably do 20 parts, it can be 40, it can be 50. Accordingly, we have to find out how many numbers, 1 by that numbers will become influence value. So, here if I do 20 radial lines, then the whole area is divided into 10 into 20, that means 200 division, then influence value of each small block will be 0.005. Now, length of the line so chosen for drawing the diagram taken as the desired depth, that means whatever line is shown, that should be the depth of the depth at which actually required to foundation. The stress to be calculated and draw the whole area in that scale. Cover the chart with the scaled down area, keeping the point of interest on the center of the diagram, and then count the number of blocks covered by the diagram, and finally, stress at that depth is given by this. Delta sigma will be equal to I, that is influence value, and N, that is number of blocks we will count, and Q is the intensity which is applied at the surface. So, by that finally, we will get the what is the pressure at particular depth. So, this one also schematically this is also explained in the next one. Suppose I will show you another foundation also. Suppose this is a foundation. Now, this foundation, and I want to find out at a point, suppose 4 meter below this point, 4 meter below this point, I have to find out the stress. Then what I have to do? I have to draw the first influence chart, and whatever chosen value used for the chart, that actually I have to take as a scale, and I suppose I have to find out 5 meter below this point, I have to find out the stress. And so, 5 meter become the 5 meter equal to whatever influence chart length, whatever length drawn below beside the influence chart, there is a line drawn. So, that line length actually you have to measure, suppose 2 centimeter or 3 centimeter, that should be equal to 5 meter. So, now with that scale I have to redraw this foundation. So, that will be, of course, it will be reduced in size. So, all size will be reduced, but you will not disturb its orientation and other things, only the similar shape, only it becomes smaller. And since I want to find out pressure at this point, as I have mentioned that you have to keep this one as the at the center of the influence chart. And after putting that, if you can count if you count the number all around, but that means in the influence chart, suppose we have something like this, and like this, like this, like this, like this. So, when it will cover, then the number of blocks will be covered by this. So, we have to count that blocks. And if I do that, next one I will show that. Suppose this is the one, and this is the influence chart, and when the foundation is drawn to a particular scale, then this foundation came here. You can see, and we are interested at this point. So, you have put this one at center, and then we have done here this, there, like this, like this, like this, and like this. We have done sorry, this is not the one, this is the one. This line should not be there. I will just remove this. So, so now this is the one is covered. Now, we have to count number of blocks. Suppose the whole blocks you have to first count 1, 2, 3, 4, 5, 6, 7, like that. You have to count whole block, how many whole blocks covered, and then some of the blocks are partially. Suppose this is partially covered, this block is partially covered. So, by just eye estimation, we can take that as a 0.3 blocks, 0.3. Similarly, this one another here another block is covered. So, that is suppose again same may be taken 0.3 or 0.25, like this. Another block here is covered. So, by eye estimation this can be taken as 0.8. Similarly, you can see this is another block covered, that may be taken as 0.6. This block is taken covered by parts, it is 0.8 or 0.9 can be taken, like that. Whatever fraction blocks are covered, that by eye estimation can be counted, and finally, it is added. This may come ultimately again 5.5 blocks, and there may be another whole blocks may be 20. So, that means you have maybe 25.5 blocks total covered by this foundation. Then if this is obtained, and then I know the influence value, it is written in this chart. You can see, since it is 200 division. So, it is 0.005. So, if I know the pressure applied on this foundation, suppose Q is 100, then you can find out your delta sigma will be 100 into 25.5 multiplied by is 0.005. So, this whatever calculation will come, that is the value for this at this point. So, at this point, and of course, 5 meter depth. And so, now sometime question may arise, if I cover keeping this point here, but I will be other way I will put, suppose the foundation, suppose I will clean it, and suppose I can put the foundation other way, suppose this way I am putting, and it will cover. So, whatever way you keep, if the point of interest is fixed, then whatever way you orient, it will cover actually same number. So, because of that, it is not necessary that this is the only orientation you have to place on the paper, but you can keep any orientation, it will ultimately count will be same. So, only thing is you have to know at what point you have to find out the pressure. Suppose I want to find out pressure now at this point, then I have to shift this point, this entire thing, and I have to bring this point here. Automatically these things will be shifted this side, and it will cover some other number. So, different number will not be same. So, this point compared to this point pressure may be less. So, accordingly it will number will change. So, you have to, so that means if I want to find out at this point, then again I have to shift entire thing, this point I have to keep here, and then with respect to this I have to draw the figure this side. So, then again he will count the number and then multiply by I and Q, then I will get the stress. Like that, any point, suppose I want to find out at this point. So, I have to keep this point here, and then I have to cover symmetrically the whatever way it is there. So, like that this is a very universal chart that any shape of foundation, suppose the foundation shape is something like this, which is unusual, but suppose I can imagine that is a foundation type. This cannot be used by Bosner's point formula or Bosner's that area integration or point corner formula, nothing it will be used here. So, instead of that, now if I want to find out pressure at this point, what I will do? I will draw this this area in a particular scale and shift here, this point and this point I will keep here, and then count number of blocks covered, and then I will get the sigma z into q into number of blocks covered multiplied by influence chart will be your pressure at particular depth. So, this is about an influence chart. This is very useful when we did not have calculator and or computer, people used to enjoy this type of chart, but it has some technique you can see. Now, I will go next. I have now discussed a number of things that point load, and then your point load, how to apply different ways, that is also we have discussed. Then integration, corner formula, then Newmark's chart, but in practice what we do? Most of the time so much calculation we sometimes may not do, and there is a approximate method by which we can do, and you can see in this figure you can see that there is a foundation, suppose is shown here, and maybe this is extended this side, and this is the width, and then approximately we can assume that vertical pressure dispersed with some particular angle. Okay. So, if I apply load here, so load will not be vertically, it will go up to this. So, it will be slowly dispersed over depth. So, if I apply load here, this much area, it will be dispersed over depth like this. So, similarly here, so this dispersion, when the stronger soil, dispersion will be more, but when the soil is weak, then dispersion will be less. So, but in most common practical work, most of the time in practical work, we generally take one vertical, two vertical, one horizontal, but anything it can be. So, that is why I am showing here first generalized one vertical NH horizontal. Okay. So, that is what. So, in that case, that means at any depth we can imagine the footing area is increasing. Here actually it was B. Now, because of the dispersion I can consider this is the footing width. So, what is the footing width now? If I one vertical NH horizontal, if I take N horizontal, then what happen? It is N times Z, it will be N times Z will be, and this will be B. This is B projection. So, ultimately your width will be B plus 2 times N Z, and now N if it is 0.5. So, B plus Z it will be. So, it will be B plus Z. So, that means I can consider the widening of footing. Suppose at this depth whatever q was there. So, it is q into multiplied by some footing area length into or B into suppose unit area I will take, that was the load, and at this depth it will be same q this load divided by, now area will be changing now, area will be changing. So, that the width will become B plus Z, and similarly unit width whatever they are correspondingly that will also change. So, that divided by this, that will give you whatever pressure intensity was here at this point, pressure intensity will be reduced. So, that is the one generally we take, that is called trapezoidal dispersion we can consider. That is the way simple way sometime we calculate in practice. I will show the next slide also. So, this is actually as I have told one vertical N horizontal, here actually 2 horizontal 1 vertical, 2 vertical 1 horizontal, this is the standard thing we use, and if you use this, then this become B, this become B, and this become Z by 2, Z by 2. So, ultimately this width become B plus Z. So, if it is a rectangular footing, B plus Z will be width and length also will become L plus Z. So, at this depth area will be this multiplied by this. So, if I do this way, then your so this is the one in 3 dimensional we try to show here. Sometime length people take as a 2L and 2B. If I remove this, if I remove this, if I remove this, F equal to B by F equal to F by del sigma equal to F by B into L, B multiplied by L, and at this depth, in that case if it is B, then it will be B plus Z, and this one also it will become L plus Z. So, width at this depth will be B plus Z, at this depth L plus Z. So, what will be the pressure at this depth? F Z B plus Z L plus Z. So, it was F Z initially at this depth at surface your force suppose Q, and then at the surface suppose B into L it was, that was a Q, and now at a depth Z sigma Z will be Q divided by B plus Z into L, multiplied by L plus Z. So, this if I do this, so compared to this width is bigger, this width is bigger. So, ultimately pressure at this point will be reduced. So, that is the way sometime we calculate approximately pressure at any depth, and unlike whatever method we have discussed, but when we have enough time and scope we do that, but most of the approximate calculation or sometime we follow this, the trapezoidal distribution, and as I have mentioned that one vertical and n horizontal, that is one very generalized way, but most common dispersion we consider 2 vertical 1 horizontal, and if it is done with 2 vertical 1 horizontal, then at a depth Z your increased width will be B plus Z and increased length will be L plus Z. How it is that if I draw this will be B and this will be Z by 2, this will be Z by 2, and so finally this. So, this is the way we can find out the delta sigma, and that is the so I will try to discuss other part, that means how to I have discussed different methods, how to apply these methods for finding out the delta sigma. I will take several problems in the subsequent few lectures. Okay, thank you.